Hello, this is Mr. Huff, and I want to go over the Introduction to Engineering and Design Semester 1 exam review. The first thing I want to talk about, and this is not one of the first things we talked about in class, but it's what I want to talk about first here, is look at the normal distribution. So here we have a normal distribution, and you can see this bell-shaped curve, and then we divide this into 6 equal pieces, plus or minus 3 standard deviations. So if you look at the center, this line in the center represents the mean. This first arrow at the top, this represents the zone that is plus or minus 1 standard deviation. This represents the zone that is plus or minus 2 standard deviations, and this represents a zone that is plus or minus 3 standard deviations. Some numbers you need to write down, make sure you have them in your notebook, are these. This first zone represents 68% of the data in this bell curve. The second zone, from plus or minus 2 standard deviations, this represents 95% of the data in this bell curve, and for plus or minus 3 standard deviations, that's 99.7% of the data in that bell curve. So that is the first thing we want to talk about. The other thing we want to talk about is the study guide itself. So let's go through this. You need to go through mypltw.org and look at the definitions for things like innovation, analysis, invention, and case study. I want to focus on the difference between an innovation and an invention first. An invention is where someone makes something completely new. They come up with a way to solve a problem that's never been done before. And innovation is where you take an invention and improve it. You need to compare a scientist and an engineer. The easiest way is to think about the questions that they answer. A scientist tries to answer, why does this happen? They observe something in nature and they try to understand why it does that. An engineer always starts with a problem to solve. An engineer tries to come up with a way to solve a problem. So the scientist asks why, and the engineer asks how to solve. You need to be able to compare and contrast, not contracts. Compare and contrast. You need to be able to compare and contrast measurement, accuracy, and precision. This is also in some of the mypltw notes. I like to explain it with a target. An accurate measurement is one that is close to the center of the target. So it's the root word is for accuracy is the meaning, it means truth, what is actually there. Precision has to do with, can you do it over and over again? If you have a target where you have a bunch of bullet holes all together, really tightly grouped, but they're not in the center, that's precise, but not necessarily accurate. You need to compare biomedical engineers and civil engineers, chemical engineers, and mechanical engineers. Identify what these guys do. For instance, biomedical engineers look at how to solve problems in medicine. A lot of times you're looking at things like prosthetics and things like that they will design. Civil engineers design buildings and cities, and they try to figure out how to make things like earthquake proof. How do you make sure traffic flows properly? That sort of thing. How do you keep people safe in a city? That sort of thing. Chemical engineers look at how do you use chemistry to solve problems. Mechanical engineers try to figure out how to build machines and systems and understand how stresses work in different materials to build a device or make things cheaper and stronger. You need to go back and look at your ideas about notebooks and documentation. So you need to know the characteristics of a properly made engineering notebook. What can you do? What should you do? What should you never do? Like tear pages out. Or like scribble out entire sections or leave big chunks of your pages blank, that sort of thing. Don't destroy the notebook. You need to know the definition of a portfolio, and you need to know how a portfolio is different than an engineering notebook. For the engineering design process, you need to know the steps and the order of the engineering design process. I gave you a handout at the start of the year. It's also well documented in mypltw.org. You need to understand what happens in each step, so you should be able to think about what we're doing and figure out what step that is. You also need to know some of the rules for brainstorming. This one should be pretty easy. Mostly it's about letting the ideas flow, making sure everybody participates, not being critical. There's no bad ideas during brainstorming. So if someone says something crazy, you just leave it out there, and sometimes those crazy ideas turn into really good solutions. For the drawing, you need to be able to recognize and identify the different kinds of drawings, like sketches and perspective sketches, isometric and obliques, that sort of thing. You should be able to distinguish between those. Then you also need to be able to identify the different types of lines used in engineering drawings. Is it a hidden line, an object line, a construction line, that sort of thing. You need to look at the quality of 3D sketches. What makes a 3D sketch easy to interpret is usually how it is shaded. So that shading really helps us see this, especially like on an isometric drawing. It's really hard to understand an isometric drawing of cubes until you shade the front darker and the sides light and leave the tops white. How do you choose the front view of a part? You want to find the side that gives you the most information about the part. So you'll have to analytically look at it as at a feature and tell me which side, or a part, and tell me which side is going to be the front. What are the most commonly used views in an orthographic drawing? This is the multi-view drawing. We typically default to top, front, and right. The only time we include a back view or a bottom view or a left view is if there is something that we cannot see in the top, front, right view. You want to go over the 16 rules of dimensioning. What I'm really looking for here is if I gave you an orthographic drawing, you would need to look at a view and tell me how many measurements you would need to provide to fully understand the dimension of that part without giving me too many dimensions, or if you were to describe the width and height of an object. So think about those dimensioning rules. Measurements and statistics, you need to know how to choose the best measurement tool for a specific measurement. So in this question it'll say you're going to measure a blank, and here are 4 different things to choose from. Which one is the best tool? You need to be able to use dimensional analysis to convert measurements from one unit to another. And you should have some of these notes written down. So unit conversions, you'll have to do this by hand during the test. If you go to Google, it's going to be considered cheating. So don't do that. You need to understand how to measure using US customary and system international measurement schemes. This is going to be looking at a ruler and you tell me the measurements. You need to know what a dial caliper is and what its parts are. So the presentation about dial calipers, you need to go look at that. Add a drawing in your notebook that labels the parts. You need to be able to read a dial caliper. You need to understand and identify the symbols used in statistics formulas and their meanings. What's the symbol for the mean of the population? What's the symbol for the standard deviation of a sample? That sort of thing. You need to be able to calculate mean, median, and range. You will need to have a calculator for this exam. If you have one that you like to use, bring it. Otherwise, I will have some for you to borrow. And when we did a histogram assignment about 2 weeks ago, and you need to think about what a histogram is telling you. A histogram tells you about frequency. We've already talked about histograms and standard deviations at the start of this video, about what plus or minus 1, plus or minus 2, and plus or minus 3 standard deviations mean. You need to be able to distinguish between a normal distribution and a skewed distribution. And we talked about that in class. If not, go over your note. You need to know what the acronym CAD stands for. You need to know what you would use Inventor for, and Excel for, and PowerPoint for. You need to know the Inventor file types, like a .ipt is an Inventor part. .idw is an Inventor drawing. .ipn is an Inventor presentation, that sort of thing. And you need to know the different commands that you've used in making the puzzle cube parts. So mostly you've done 2-point rectangles and you've done extrusions and things of that nature. So that one should be pretty straightforward if you finish the puzzle cube project. And that is a quick overview of things you need to go study for through the Introduction to Engineering Study Guide.